Hello everyone, myself Angshuman Srichatak. I am a physics teacher. I am teaching physics since 12 years for 11th, 12th and integrated NEET and JEE Main. So today I am going to deliver lecture on work power energy chapter, which is very much important for NEET as well as JEE Main examination. So basically, what we need for this particular chapter, prerequisites for particular this chapter for basic knowledge, we need scalars and vectors. Obviously, NLM, Newton's laws of motion, and friction also. Circular motion as well as. So these three chapters are going to be interlinked in this. And for 11 point of view, I'm saying these three chapters. And if we correlate the chapters of 12th also, so we can add other chapters from 12th, that is electrostatics, okay, and capacitance also in this. And from second part of 11th, SSM we can add here. So these four chapters from 11th and from 12th, electrostatics is going to be included in this particular topic. So let's go to the topic. So dear viewers, in work or energy, first let us discuss what is work. So when any person who is studying physics for the first time, yeah, whoever is preparing for NEET and JEE, so let us know what is work. Generally, without physics, if we consider work, work means it is something what we are doing, something what we are doing. Forget about physics. Forget about physics. Something what we are doing, we can say it as work. We are studying, that is also work. We are doing some official work, that is also treated as work. But according to physics, these are not work. Okay. According to physics, what is work? Work is that particular parameter which involve, listen to me carefully, which involve force along with displacement, which involve force along with displacement. Force along with displacement will produce work. So how it is going to be? How it is going to be? So work, mathematically, work is given by force acting along displacement. Force acting along displacement will produce some work. So let us see. Suppose this is a path, and here there is a body of mass m, and the body is getting displaced from here to here. This is initial position, this is final position. So body is getting displaced from here to here, and this is the displacement. And the displacement is S, which happens only because of this force F. So the force F is producing displacement S. F is the force which producing displacement S. So this force is doing some work on the body. This force is doing some work. Work is produced on the body of mass m, and work is produced on the body. So work done will be given by mathematically from this concept. Force acting along displacement, that is force product of force and displacement. So we have to combine. Listen, why we are multiplying. So force acting along the displacement, that means we are simply multiplication. This is neither dot product nor cross product. We are multiplying F into S. But you will think there is formula Fs cos theta, how it comes from. So for this particular case, what is the angle between force and displacement? For this particular case, angle between force and displacement is 0 degree. So it always is not like that if every time we will take angle as 0 degree. Angle can be anything. Angle can be 0 degree, can be 1 degree, 2 degree, 3 degree, any angle we can take. So if any angle we can take, you see, if any angle we can take, then what will be the work done? So suppose here is a path, body is here, body is getting displaced like this. This is displacement S, but force is acting like this. So now see, this angle is suppose theta, this is displacement. So we have vector concept, we can resolve the force into two components. Your force is having one component like this, another component like this. This one will be F cos theta, right? This one will be F sin theta. So now see, body is having mass m. Obviously, body will have some weight mg. Okay. So F sin theta is getting cancelled by the weight, and it has no role in displacing the body. F sin theta has no role in displacing the body. So which force is displacing the body? F cos theta. So work done is producing due to the F cos theta only. So F cos theta is along the displacement. You can see what is the direction of F cos theta? This is along the displacement. So F cos theta into S. This is how we get the formula work done equal to Fs cos theta. So we can write it as F dot S. Okay. So just watching the previous slide, W equal to F. This is simple multiplication, neither dot product nor cross product. Here theta is 0 degree. But in this case, we are taking theta is any arbitrary value. Based on the value of theta, we can assume what the work done will be. Okay. So cases are generally two cases are taken, three cases actually. Theta equal to 0 degree. Obviously, work done will be plus Fs. This is sure. Theta is 180 degree. Theta is 180 degree. And work done will be minus Fs. So the students who are studying 11th, 12th, they are studying this much only, but there are more deeper concept is there. When angle between force and displacement is 0 degree, what does it mean? Whenever angle between force and displacement is 0 degree, what does it mean? Acceleration on the body is positive definitely. So velocity of the body is increasing. Clear? Velocity of the is decreasing. That means, see properly, force is dragging the body. If the theta will be 0 degree, this force will act along this direction and it will drag the body. It will drag the body along the displacement. So we can say this is work done. Work done on the body. What does it mean? Body is not doing any work. An external agent, external force is doing work on the body. Body is getting dragged by certain external force, F. Clear? So if we'll take theta as 180 degree, that means force and displacement are in opposite direction. You will say, how is it possible? If the force is dragging the body, then it is Okay, we can understand body is pulled by certain force, then it is performing certain displacement. How is it possible? Force is acting against the displacement. So how come the displacement produced along the path? So see, first let us see this is body force. It doesn't mean that body is working, body is doing some work with that force only. That is the main concept of this one. Body is doing some work, but it is doing work against the force. For example, I'm giving an example, you can understand. Motion against gravity. Very clear example, you can understand. Motion against gravity. So body is moving against gravity. So body is moving against gravity. And at that time, work done is negative. So work done will be negative. So work is done by the body. Work done by the body. When work done is positive, work done on the body. When work done is negative, work done by the body. So positive particularly angle 0 degree, negative angle 180 degree. So you can say if theta is less than 90, definitely work done will be positive. That is also a case. If theta is greater than 90, that means theta is an obtuse angle. Theta is acute angle means work done will be positive. Theta is an obtuse angle means work done will be negative. Acute angle for theta less than 90, positive work, greater than 90, negative work. Fine. So this is the fundamentals. So if we'll go for vector form, obviously work is a scalar quantity because we are showing work as a dot product of force and displacement. But considering the vector form, F will be Fx I cap plus Fy j cap plus Fz k cap. Fine. And S will be X I cap plus Y j cap plus Z k cap. So what will be the work done? Fine. Dot product. Easily you can see the formula. Okay. So what will be the work done? See, work done will be simple dot product. We are going to multiply the coefficients only. You know the formula of dot product. So what will be x into fx plus y into fy plus z into fz. Okay. So if force and displacement are given in orthogonal form, then we can calculate the work done according to this formula. So this is very simple concept. Now going to another concept. If the force is constant, all these concepts are based on only one factor for constant force. For constant force. If force is constant, then work done will be like this, constant force. So for constant force, writing work done is very much easy. W equal to Fs cos theta. Yeah, in this format, we can also calculate the work done. Here, force is constant. It is having constant magnitude. Okay. Yeah, any constant direction. But if the force is variable, how can we calculate force? Here we are calculating for constant force. Keep it in mind. This is for constant force. What will be the work for variable force? For variable force, we are going to calculate work. So let us think what is variable force. First, we should know what is variable force. Variable force, obviously, force is a vector. So its direction as well as magnitude. Suppose this is a path, and we are assuming here a force is acting, okay, like this. Suppose here a force is acting, here force is acting like this. The body is displaced, getting displaced, but at every point, we are getting different direction. Are you getting me? At every point, we are getting different direction of force. Obviously, magnitude is getting changed and direction is getting changed. So here, force is variable. So force F is function of coordinates. So it is function of X, function of Y, function of Z. So this is variable force. So if the force is variable, then how we will calculate the work done? How we will calculate the work done? See properly. So if the force is variable, so we will calculate. See, if we see the path A to B, it is very much variable, very much complicated path. So how come we find the displacement? This is definitely a distance. So using the distance, we can't calculate any work done. Let us see a small displacement ds. Obviously, ds is a small displacement. Any part, consider any part, any small part. This is suppose ds. So for this displacement and this force, what will be the work done? Obviously, a small work done will be dw. So dw will be f dot ds. So what will be the net work done for the entire path? F dot ds integration. Then what will be the exact format for work done? See, already in dot product, we have studied, see previous slide, work done will be like this. So using this concept, if we will see, if you will see work done, ds small displacement, we can write it as dx I cap plus dy j cap plus dz j cap. Then what will be work? Work will be fx dx integration plus fy dy integration plus fz dz integration. Are you getting me? We will calculate every individual x part differently, y part differently, and z part differently. This is what the work done for variable force. X part, this is for y part, and this is for z part. Obviously, force will be represented as in terms of ijk, fx I cap plus fij cap plus fz k cap. And by taking this formula, integrating, obviously force as function of x, y, z will be given. For example, F will be given as x square plus y square plus, yeah, suppose we are taking minus 3z square. Okay. So this much Newton, what will be the work when displacing from, when body is displaced from 1, 2, 3 to 3, 4, 5, like this, suppose. So we are displacing a body from this position to this position. So this is initial position, I, this is final position. So how we are going to calculate the work done from 1 to 3 point to 3, 4, 5 point. So we are, see, force is given as, force is given as x square plus y square minus 3z square. Obviously, work done will be fx dx. We are applying the formula fx dx, x square dx integration plus y square dy integration plus not plus, minus 3z square dz integration. Obviously, limit we are taking 1, 2, 3, 3, 4, 5. So here point is 1, 2, 3, initial point, final point 3, 4, 5. So we are putting limits. We are putting limits. This is x1, y1, z1. This is x2, y2, z2. So from x1, what is the limit of the x? 1 to 3. What is the limit of y? That is 2 to 4. What is the limit of z? That is 3 to 5. Okay. So here force generally will be given in vector form. That means F vector equal to this much. This is I cap. Okay. This much J cap. This much K cap. Okay. Sometimes it is also given in function, if in algebraic function without I cap, J cap, K cap. Okay. So using only one variable or two variable, and that this type of questions are also come. Okay. Okay. Here I cap, J cap, K cap in this format also force is given. Okay. So now it is very easy to calculate x cube by 3 limit 1 to 3 y cube by 3 limit 2 to 4 minus 3 z cube by 3 limit 3 to 5. So this much work we have to calculate. So 1 by 3, here we are taking 9 minus 1, okay, plus 1 by 3, 64 minus 8, minus here 3 getting cancelled, z cube 5, 125 minus 27. So now we can calculate 8 by 3 plus 56 by 3, sorry, by 3 minus 98. So now we can calculate, finalize this much joule. Okay, students. So obviously, SI in SI system, force is given. So answer will be in SI. Okay. So this is how we can calculate the work done due to a variable force. So now coming for the concept, how if the force is variable, several questions comes into mind. If force is variable, so what type of variation is there? If force is variable, it can have two types of variation. One, force is vary with respect to position. Force vary with respect to time. For the first one, we have already written the formula for this first one. What will be the formula for the first one? So work done will be F dx integration. Obviously, we will put limit x1 to x2. Here, this is very simple. But what about this? If the force is function of time, then how we will calculate the work done? So for this, see properly. Force is function of time means, see, we have already studied Newton's law. So in Newton's law, force is equal to dp by dt. Obviously, momentum is function of time, then definitely force will be function of time. Then if the question it is given that force is function of time, then how to calculate work done? So see, use first formula. This is the main formula, f dx integration. Okay. So we have to represent it in terms of t. So dx is the displacement. Students, you know velocity equal to dx by dt, obviously derivative of displacement with respect to time. Then you can replace that dx as v dt. Now we have converted the variable from x to t. We have converted the variable from displacement to time. Now you can solve the problem easily because f is given as function of time. And how you have to calculate the velocity? So velocity you can calculate as function of time. How? See, v equal to a dt integration of acceleration. Obviously, in question, maximum questions every time when it is coming, mass is given. So force by mass dt integration. You can calculate the velocity. So putting this, so you can calculate whatever time limit will be given, you can calculate the work done. Fine. So this is about the force, okay, and how work done is performed. Okay, fine. Coming to the next concept, that's how work energy theorem works. Work energy theorem. This theorem basically states work done by all the forces. Work done by all forces. Definitely, the variety of forces are there, contact forces, different contact forces, different non-contact forces. Work done by all the forces is equal to change in kinetic energy. So this concept is very much important, which is going to be applied, and solving problem using this concept is very much easy. And you, in short duration, in short tricks, we can solve the problems using work energy theorem. You can solve the problems in using NLM method, using equation of kinematics, by using traditional formula F equal to W equal to Fs cos theta. But when we will apply work energy theorem, problem will be solved very soon. Change in kinetic energy. So before going to this formula, let us see why this theorem is applied and what are the basic requirements. So main concept of this formula is all the forces. What do you mean by all the forces in this topic? So there are two types of forces, students, you know, for which we are doing work. One is conservative force. Another is non-conservative. Work done due to conservative force and work done due to non-conservative force. How we are doing and how we are applying. See, work done due to conservative force. Work done due to conservative force due to conservative forces. Especially this work done is independent of work, sorry, independent of path, completely dependent on point, independent of path. It depends on initial and final point. So if we will calculate work done due to conservative force, I'm giving symbol as like this, will be f dx integration, and it is independent of path. I will simply put initial point and final point. Okay. So this formula for variable force we are applying. this is valid for conservative force, and it is dependent on only initial and final point. So now what do you mean by conservative and non-conservative force? Simple, very simple concept, students. Conservative means all the non-contact force, all the non-contact force which are conservative. Non-contact forces, you can say, or you can say field forces. Field. Field force you can know, you can understand. The force which is having range without any physical contact, without any actual contact, it can exert its impact. It can exert its effect. For example, gravitational force. Gravitational force, Coulomb's force, obviously electrostatics, magnetic force. So these forces are conservative forces. So these are non-contact forces. So these non-contact forces, which are field forces, which is having certain range, certain field within which we can experience. Beyond this field, within gravitational field, we can experience gravitational force. Within electric field, we can experience Coulomb's force. Within magnetic field, we can experience magnetic force. So that's why remember only one trick. All the field forces, all the non-contact forces are conservative in nature. And work done due to these forces is independent of path. It is only dependent on initial and final point. Fine? Okay. But for non-conservative forces, it is path dependent. Path dependent. Example of non-conservative forces. Very simple, frictional forces. Obviously, it is path dependent because friction depends on the common area of contact. So obviously, it is path dependent. Okay, fine. Conservative force is independent of path followed, and non-conservative force is dependent on path followed. Example of non-conservative frictional force. Example of conservative force, gravitational force, Coulomb's force, magnetic force, spring force is also there. Okay, spring force. Fine. Okay, thank you.